Hi guys, how are you doing today?
Good.
Good.
Great. So today we're going to talk about solving two-step equations. Before we move on, we should establish what's going on with this equation that I've listed up here. In this equation, the left side is equal to the right side. The right side is relatively straightforward. We have the number 7. The left side, on the other hand, has this variable x in the expression, which is an unknown. It's what we're trying to solve for. So saying this in plain English, this equation is equivalent to the following question. What number times 2 plus 5 gives us 7? So to solve this equation, we're going to use a method called inverse operations. The ultimate goal of inverse operations is to isolate the variable x and give us an expression of this form. X equals some number. To do that, we want to chip away at the things surrounding x until we're able to successfully isolate it. So I mentioned that this method is called inverse operations. We should first establish what these inverse operations are. An inverse operation is an operation that cancels another operation out. You can think of them as opposites. So for example, let's say we have a set of 5 apples, and we add 2 apples to it. How do you get back to the original state? Well, you remove the 2 apples that you just added to get back to the original 5. So on that note, what would the inverse of addition be? Yeah, go ahead, Mariah.
Subtraction?
That's perfect. So addition and subtraction are inverses of each other. The other operation we need to consider is multiplication. Does anyone have any idea what the opposite of multiplication might be? Go ahead, Ethan.
Division?
That's perfect. So here we have our pairs of inverse operations, and we're going to use these to solve this equation. So now, starting from the original equation, we want to start, as I mentioned earlier, chipping away at everything surrounding our variable x so that we can isolate it. And before we move on, there's something important I should mention. I'm sure a lot of you guys remember PEMDAS from some of your earlier math classes, or order of operations. In other words, when we're evaluating an expression, we go through following this order. We'll first do whatever is in the parentheses, then we'll apply exponents, multiplication and division, and addition and subtraction last. With inverse operations, however, we're going to work in the reverse direction, because in some sense we're working backwards. So we're actually going to work in the reverse direction. First, getting rid of our addition and our subtraction operations, then getting rid of our multiplication and division, and finally ending with what's in parentheses. So, moving back to this equation, we want to first get rid of the plus 5, because that falls in this addition category. We're moving backwards now. So, does anyone have any idea what the opposite of adding 5 might be? Anyone have any idea? Go ahead, Mariah.
Subtracting 5?
That's exactly right. So we're going to subtract 5 from this expression in order to cancel out the plus 5. Now here's where the final step in inverse operations that I need to mention comes up. If we apply some operation to one side of the equation, we have to apply it to the other as well. Think of a weighing scale. If the balance is equal, and let's say all of a sudden we add 5 pounds to the left side is going to be heavier. What are we going to have to do to the other side to maintain that balance? Well, we'll also have to add 5 to bring it back into equilibrium. So here, we're going to not only subtract 5 from the left side of the equation, but also from the right side. So now that we've done that, the plus 5 and the minus 5 cancel out. And we can go on to the next line. 2x equals, and 7 minus 5 is going to give us 2. So now, we have to apply our second step. As I mentioned, these are two-step equations. So right here, we have 2 times x equals 2. Does anyone have any idea what the opposite of multiplying by 2 is? Go ahead, Ethan.
Divided by 2?
That's perfect. So we're going to divide not only the left side by 2, but as I mentioned earlier, we're also going to divide the right side by 2. Apply the same operation to keep things in balance. These are going to cancel each other out, and we're going to be left with x equals 2 divided by 2, or 1. And that's going to give us our final solution. As I mentioned earlier, we now have an expression where x is isolated and set equal to some value. And now, remember last class, we talked about solving two-step equations. So I wrote a song for you guys to help you remember the key concepts. Are any of you guys Aretha Franklin fans?
R-E-S-P-E-C-T.
Find out what it means to me. Aretha Franklin is my favorite. So I've got 3 lines right here, mimicking the tune to R-E-S-P-E-C-T. Starting from the top. Isolate the X for me. Guys follow after?
Isolate the X for me.
S-A-D and M-E-P.
S-A-D and M-E-P.
Apply it to both sides, you're free, because the answer you will see. It's okay, keep on trying, guys, you got this.
Apply it to both sides, you're free. Because the answer you will see.
Alright, let's do the whole thing now. Isolate the X for me, S-A-D and M-E-P. Apply it to both sides, you're free, because the answer you will see.